All right, this is lecture 2 on chapter 10 with chemical reactions. And so we're starting here with steps for balancing chemical equations. So the first thing you need to do is, if the equation is given in words, which sometimes it will be, you need to write it into a formula with the reactants and the products. So let's take a look at what this might look like. So natural gas, CH4, burns by reacting with oxygen to produce carbon dioxide and water vapor. So this is actually a problem I would expect you to be able to write, because all of the chemical formulas here you would be able to figure out except for the natural gas, that's why that one is given to you. So what do you mean I can figure it out? Well, you know that oxygen is a gas that always is in 2-atom form, right? We know that oxygen is O2. It's a diatomic gas because it needs to make those 2 bonds in order to fill its outer electron shell. That's why we always see it written as O2 or bound to another element. Carbon dioxide, well, this one is named with the rules of our covalent compounds. You know that because it's got di in it. If it's got one of those prefixes, you know that means it's a covalent compound. So carbon and oxygen, and it's di, so 2. And water, you should know that one, so it's H2O. Okay, so you've got now all of the chemical equations that you need, or I'm sorry, chemical formulas that you need. You've got it for natural gas, you've got oxygen, carbon dioxide, and water. Those are the guys that are in the equation. Now you just need to know where to put them as far as on which side of the arrow. So the problem will give you an indication of who is who. So in this case, it actually tells you natural gas burns by reacting with oxygen. So that tells you that natural gas and oxygen are the reactants, right? So these guys, the arrow is going to point away from, and it then tells you to produce. The arrow points to the products. The arrow means produce, carbon dioxide, and water vapor. So there's our formula. So methane plus oxygen produces or yields carbon dioxide and H2O. So that's our first step if it's in words. If it's already given to you here, then you can go to the next step. The next step is to make an inventory of each kind of atom on both sides of the equation. So what do I mean by that? Well, the easiest way to do that is to actually write down the numbers. And if there's an imbalance, keep going. So let's take a look. And for people who are learning how to do this, this is how I actually recommend you do it. So on the left side, you've got carbon 1, you've got hydrogen, and we've got 4 of those. So 4, oxygen 2. On the product side, let me get rid of that. There we go. Okay. So on the product side, we've got 1 carbon, right? Because we just have the 1 here, because this subscript only multiplies the guy that it follows, right? And that's why we only have 4 hydrogen. So we've got oxygen. Now we've got 2 here, but we've got 1 over here. So we actually have 3 oxygen. And then hydrogen, we've just got the 2. So we've got our list written out, and it shows, yep, we are not balanced. We have balance for the carbons, but we've got 4 hydrogens versus 2 hydrogens, and 2 oxygens versus 3 oxygens. So we have to keep going. So what do we need to do? Figure out where to put coefficients in to balance the equation. And remember, the coefficient applies to all elements in the compound it's put in front of. So if you've got CO2 and you put a 2 in front of it, that means you've got now 2 carbons and 4 oxygens, because you have to multiply the coefficient and the subscript to get your total. Okay, so again, this will get you 2 carbons and 4 oxygens, because this is going to affect everything in the compound that follows the number. All right, so let's take a look. There's another example. So H2O, so you've got a 2. That means you're going to have 4 hydrogens and 2 oxygens. Right? So you're going to keep repeating steps 2 and 3 until you get all the atoms equal on both sides of the equation. I recommend that you practice this with pencil, because you're probably going to erase several times when you're first learning how to do this, or if you haven't done it in a while. So if we do this equation, if we check now, I've put a 2 in front of the oxygen on the reactant side and a 2 in front of the hydrogen on the O2 on the water, because that was my guess. So let's take a look. So we'll do carbon, hydrogen, oxygen. We're going to check it. So on this side, carbon, we have 1. And usually if you have one that's balanced, don't put anything in front of it first. Try and balance the ones that aren't in the right number. Okay, so we've got hydrogen, 4. Cool. And oxygen, we've got 4. So on this side, we've got carbon, 1. All right, that matches. Hydrogen. How many do we have now? Well, 2 times 2 gets us 4 hydrogen. And oxygen, we've got 2 here, and we've got 2 here. So that gets us 4. And so that means that the equation is balanced and we are good to go. So we're going to do some practice ones. So we're going to first look at another word problem. This one's very similar to what we just saw. So instead, we're going to burn, instead of methane, we're going to burn propane. This is what you do like on your grill. All right. So we've got propane combines with oxygen when burning to yield carbon dioxide and water vapor. What's the balanced equation? Now, the words are a little different, but we've got the same sort of thing. Combines sounds like reacts. It puts them together, all right? And yield is the same as produce. So the arrow is always going to point towards what is being made. That's the yield. So we know that carbon dioxide, CO2, and we know water. And when you do this, leave yourself room in front of the compounds and elements so that you can write in the coefficients. So they gave us propane. So you're going to C3H8, and we're going to add that to our O2. All right, so like I said, first thing to do is to check out what we've got on each side. So we've got 3 carbon, we've got 8 hydrogen, and 2 oxygen. Over here, we've got 1 carbon, we've got 2 hydrogen, and 2 plus 1 more, we've got 3 oxygen. All right, so where do we start? Well, you can pick any element you want to try to work on. So I think I want to try and start balancing. Let's try the carbon first. Okay, so we're going to try and balance the carbon first. We have 3 on this side. So to balance it on this side, we're going to need 3, right? So let's change our totals down here to match. So we still have 3 because we didn't add a coefficient here. That means we'll have 3 over here. So cross this out, and we now have 3 carbon. And did that change our number of oxygen? Yeah. So now we have 3 times 2, so 6 and 7. Now don't panic yet, because we still have other things that we have to balance. So we can still change that number. So we've got our carbons balanced. Let's see if we can balance our hydrogens. So we have 8 hydrogens over here, only 2 here. So the easiest way to do that is to increase the hydrogens over here, right? So if we add a 4 in front of this one, that gets us our 8 hydrogens, right? So that means we'd have 8 here, and we'd have 8 hydrogens here. Cool. And now how many oxygens do we have? Because we changed the total again. So 3 times 2, that's 6. 6, 7, 8, 9, 10. So we've changed that total one more time to 10. So now we have 10 oxygens on this side, just 2 over here. So it's actually a little bit of an easy fix because we can just put a 5 in front of this oxygen, and that gets us 10. So 10 for the oxygen. Now we're balanced. So we have propane plus 5 oxygen is going to produce 3 carbon dioxide and 4 water molecules in a balanced equation. So I'm going to stop there and pick up in the next video with some more practice equations, and we'll see you then.